let us look at the final topic of this chapter, that's binomial theorem for any index, right? So formula, as you can see, when you had 1 plus x whole power n, the expansion to this was 1 plus nc1x plus nc2x square plus nc3x cube. Likewise, up to ncn x power n. Now here, the things are very much similar when it comes to binomial theorem for any index. So the formula starts in a similar manner. You have 1 plus, so you have 1 plus x whole power n. I'll show you what the difference between this and this is. Why is that this formula is going up to infinity and this is just stopping at ncn whole power x plus 1. So as you know, if your n is an integer, then number of terms in this expansion is n plus 1. But the number of terms in this expansion, if n is a rational number and not just an integer, then it just goes on up to infinity. Especially, in fact, when your mod x is less than 1. So if the modulus of this value is less than 1 and n is a rational number, then what you have to accept for now is that the number of terms just keeps on going. It just tends to infinity. So something like if you have 1 plus x whole power minus 2, and if your mod x is less than 1, right, then it just keeps going. The number of terms are infinite. So it starts in a similar manner. You have 1 plus nc1x, and this n into n minus 1 by 2, what is it? It's actually nc2, right? Because you have n factorial divided by n minus 2 factorial into 2 factorial, which is n into n minus 1, and n minus 2 factorial will cancel, and this is n into n minus 1 by 2. This is actually nc2 into x square only. And as you can see, this n into n minus 1 into n minus 2 by 3 factorial, that's actually your nc3, because you have n factorial into n minus 3 factorial divided by, divided by n minus 3 factorial into 3 factorial. So when you expand this, you will have n into n minus 1 into n minus 2 into n minus 3 factorial divided by n minus 3 factorial into 3 factorial. This n minus 3 factorial gets cancelled. N into n minus 1 into n minus 2 by 3 factorial is what you have. So that's nc3. So if you can see, it's just going, but just that, it will just keep going up to infinity. It won't stop at ncn x power n. That happens when n is a rational number. For instance, if you have something like 1 plus x whole power 4 by 3. Now this is a rational number, not an integer, so you can't have 4 by 3 plus 1 number of terms. So that's how you have to remember it. Whenever you have a rational number, so that your n is not simply an integer, then the number of terms keeps on going to infinity if this mod x is less than 1. That's the condition. So the formula that you're seeing right now, that's valid if your n is a rational number and if your mod x is less than 1. If your mod x is greater than 1, then no, you can't do this, right? So the formula for mod x greater than 1 is not something that's of importance to you, because mostly if you are asked about this chapter, about this subtopic, then it will be for mod x less than 1. In fact, I don't even think it's in the portion of JEE Advanced or maybe JEE Mains. You can just have a look, but I just thought I should just give it to you, maybe for boards or something. So for instance, 1 plus x whole power minus 2. How do I get the expansion? I'll just place it here. Remember, I'm assuming that my mod x is less than 1. So 1 plus x whole power minus 2. How do you get the expansion? 1, instead of n, I'll put minus 2, minus 2x. Instead of n, I'll put minus 2, what I'll get is plus 3 x square. You can put that and check. Instead of n, I'll put minus 2, I'll get minus 4x cube. So like that, it just keeps going. So this is the formula. This is the main formula that you're going to use for the expansion. So I suggest you just remember it. It's very similar to this. Just that what you have to recognize is if your n is a rational number and if this mod x is less than 1, then this expansion just keeps going, right? So this was the binomial theorem for any index. With this, we complete the basics of the chapter binomial theorem. We've covered all the basic concepts. From here, it's upon you to do problems and gain the required grip on this topic as far as the examination is concerned. Let's move on to the next chapter.